just do this shit.
Independent. Independent is something. Wow, I graduated high school. I still don't know.
You got this.
Is independent the one that you're manipulating? And is dependent the one you're measuring? Oh, okay.
So if I was like, I want to see what sleep deprivation would do on people and how that would affect their driving skills or conducting a plane. So I'm gonna just sleep deprive one group, and then sleep deprive one group, and then keep one group like sleeping, and then have them fly a plane. What would be the independent variable? Actually, and think like I wanted to see. There's like maybe the computer can like tell how well they fly the plane on a scale of like 1 to 10, maybe.
So,
what would be the independent?
Sleep, quality of sleep, or just hours of sleep, and wouldn't that be independent?
Independent variable.
And then the flying test score is dependent.
And what type of measure is this? Nominal, ordinal?
Ordinal. No, nominal. Because no sleep or yes sleep.
Yeah.
And that thing, 1 to 10, how about 0 to 10?
Okay, 0 to 10.
Scale.
Yeah, scale. I mean, technically, I didn't say that, like, maybe 0 to 1 is different from 1 to 2, and maybe 2 to 3, but I'll give it to you. I don't really care. And it's not called scale, it's called, imagine it's all, like, perfectly normal, and it has a true 0, it's called...
What?
It's not called scale.
What?
It's... So these are the 4 types.
Wait, I thought that was scale, but oh, you're right. Rational, no. Radical, no. What? Rational? No.
No, it's not N. You got it. One more letter. One letter. We're playing hangman now.
Ratio.
Yeah, ratio.
Oh my god, I'm so stupid.
No, you're not. Just think film noir. Like, I think like film noir, and I relate it to Crete, which is just me. And I think, oh, so N is categorized. Is it categorizable? Ordinal? Is it rankable? Interval? Is it equal? R? Is there a true 0? And that's it.
And then that would be a correlational study, because you're saying sleep will affect your performance.
Well, if I just like imagine I randomly sampled and I like took random ass people from all over the world, and I made sure that there is no other variables. So would this be correlational or would it be experimental?
Experimental, because you're having
Yep.
separate things.
You're right. So yeah, the main things that we need to know is it independent or is it dependent? What kind of scale is it? Noir. Is it experimental? Mental, or is it correlation? Or they call it quasi.
What the heck is that?
Experimental, it's the same thing.
Can you define experimental or differentiate it, like experiment and correlation?
So there are some things that we're just not allowed to do. Like if I proposed we sleep deprive people, the IRB would basically be like, no, that's torture. You can't do that. And so what people have to do sometimes is they have to take pre-existing groups. Say I wanted to study cancer, I couldn't give one group cancer and then have a non-cancerous group.
Right.
But I could go to hospitals and I could gather people who already had cancer. So it's like an ethical loophole. So, but the thing is that you're not random sampling then. The people at the hospital, imagine I was seeing if they're happy or if they're sad. And, you know, I'm just studying the cancer. I can't say that it's experimental because these groups already existed. I'm not random sampling it.
So if you random sampling it, that's correlational?
If you random sample it, then it's experimental.
Awesome.
Think. Because what random sampling is trying to do is it's just trying to make it more generalizable. If the groups already existed and say I was studying happiness and sadness, it could be that just people in the hospital are generally sad. It could be like unrelated to their cancer. So I can't say that one causes the other if the groups already exist.
So correlational would be just like selective. So
Pre-existing.
it's not random.
It's not random.
Pre-existing groups.
I'll write it down.
It's not as generalizable, or is it generalizable? Not
Experimental and correlation. This is random sampling. This is not random sampling. This, you can say, like, causation. One caused the other. This one, you can't say it. It's caused. This is more generalizable, whereas this is not generalizable. Yeah.
Thank you.
Let me think about it stuff. What else do we need to know?
I have a list. Do you want me to read it?
Yeah. Let's go down it.
Measure parameter or statistic, continuous or discrete. That's like parameter and statistics is like statistics is sample. Parameter is for.
And which one uses Greek and which one uses English?
Greek population. English letters, samples.
Look at you. What else? You said discrete versus continuous? What's the difference?
Discrete has like, it's discrete. It has endings. Like, let's say.
Imagine I don't know what discrete means in English.
D-I-S.
Define it for me.
Discrete is like, it kind of ends. Does that make sense?
On a number line, in time, in what?
So like, let's say we're having an experiment.
On a clock.
And then we're having an experiment to see how long this kid is gonna, like, make a castle out of Play-Doh. My kid is gonna have a limited time, so like he or she can just take whatever time. But your kid will have a time limit of 3 hours. That mine is continuous and yours is discrete. Because it has a limit.
Okay.
And yeah.
Okay.
Yeah. Does that make sense? Yeah. Or like, or if you're talking about people would be continuous, not discrete, because no. People is discrete and it's not continuous because continuous also includes like decimal points and decimal points and decimal points. And discrete are like solid values like 1, 2, 3, not 1.7, 2.8. So
if I was measuring the temperature in a room, is that discrete or continuous?
Continuous.
What about people in a class?
That is discrete.
What about if I was measuring reaction time in seconds?
Continuous.
What kind of graph does continuous? Yeah.
Yay!
What kind of graph is discrete?
Bar graph.
And what about continuous?
Histogram.
And how do they differ, like visually?
Bar graph. Histogram.
Mm-hmm.
Yeah. I don't want to take too much of the ink. Markers are expensive. You should
Yeah.
steal it from school.
Honestly. So if I gave you a data set,
I would steal it before I graduate. Like, just the whole stuff. Yeah.
put that on a histogram.
Instagram. 1, 2, 2. So that's 1 and that's 2, 2. 1, 3. And 1, 4.
Mhm.
And bar graph would be.
Mm.
Yes.
Now, if she asked that on the test, would you draw just that?
Oh, she wants this thing. What is this called again?
Mm.
Is this what you want?
That's about the polygon. That's a polygon. What I'm talking about is you would have to do axes. You couldn't just write 1, 2, 3, 4. You would probably have to put it on like a little. Okay, wait. It's actually 1, 2, 3, 4. It's actually from the middle of each.
Oh, wait, how about for bar graphs? Where would
For
those
bar
be?
graphs, so what I like to think of is when I'm drawing a histogram, you just do it by the half point. It's 1,
Oh, yeah, that
2,
was my whole thing.
3,
Right.
4. But when you're doing it on a histogram, it's by threes.
What?
It's
Wait, what?
1, and look at this. So this would be 1, 2, 3, 4, right?
Yeah.
You gotta do it like this,
That's crazy.
right?
Okay.
Because it has to be the middle point.
Oh.
So this one you just do the half point.
Mm-hmm.
This one you have to do the thirds.
I'm curious how your mind works. Like, did you just come up with that on the spot, or did you think about it before?
It's just how it exists in my mind.
That's.
I don't think
did
even.
you think about it before, like when you were reviewing, like, or did you just come up with that, like?
I
on the
have
spot?
to, in my brain, I don't think about words. I think about like
Numbers
lists of like how to do things.
Mm-hmm.
So like step 1, draw. Step 2, is it a bar graph or is it a histogram?
Mm-hmm.
And then decide based off that, like or
So the whole 1/3 thing, like, did you think of that before, like, reviewing or before?
I thought of that when I saw it on the slide.
Wow. Dang. Are you sure you're not like one of these?
I like
people?
kind of have like
My mind
weird ass ADHD, so it's like kind of like that.
That's. I mean. Wait. ADHD. Isn't that attention?
Deficit disorder,
Yeah.
It's like I can't focus.
Deficit, like you. Wow.
Well, the thing is I can't think in words. She's
Yeah, me neither.
constantly saying words,
Yeah, I
and I'm
feel
like
that.
trying to think like
that.
she's like it's like I fail to do the null of the and there's so many positive negatives it's hard.
Whiteboard.
Right?
I use like a bunch of symbols and shit that I
Right?
don't understand. Like, oh yes, I get that.
I'm so visual. I need that. Right?
Yeah.
Okay. So I give you that data set.
Yes. So for his histogram, it's in the middle. Right?
Mhm.
Like 1,
So what
2,
it- yeah.
3, 4. But then if you're drawing bar graphs, it's still 1, 2, 3, 4, but it's like 1/3. So there's
Try and see if you can draw it. Start from scratch.
1, 2, 3, 4. That would be histogram. No, bar graph.
Mm-hmm.
And then for histograms, it's still in the middle.
Mm-hmm.
It's connected.
Yeah. It's connected, yeah. Mm-hmm.
Yes.
And then the thing you were talking about is called the frequency polygon.
Yeah.
And that is from the middle. You're right. Try drawing out what that would look like.
Let's see.
Would you use a histogram or a bar graph?
Both.
You would use a histogram. Because it's kind of hard to connect when you have a bar graph. You know, they're all separate.
Oh. Right. Yeah. Okay. That's But
Yep.
But it doesn't touch the x-axis, right?
No, it connects to 0 at the end. Because the point of the frequency polygon is that it's a measure of area. So it'll be like that. Now, what about the cumulative frequency polygon?
What now?
There's a cumulative percentage, cumulative percentage polygon.
Cumulative percentage polygon, what the heck is that?
So like it's the same thing with the histograms, right? But
Yeah.
it's like, remember when we had to do like data points, and then we had to do frequency, and then we had to do cumulative frequency, and then we had to do relative frequency?
No.
And then we had to do cumulative relative frequency.
No.
And then cumulative percentage frequency. Is it on there? If it's not, then we don't have to do it. Frequency distributions, babe. And chart. So this is chapter 2. And we did it together. We did it together the first time we met.
Isn't it the slope thingies? You know?
Kind of.
Like
Yeah.
positively skewed, negatively
Oh,
skewed.
wait, that was last time we met.
Ah!
And that's skew. So you remember skew.
Frequency distributions. Because I remember.
It's like let me show you in the table, or actually let me just show you with her notes. Yeah. Do you usually use Safari? Would that work? Yeah. And then go to, let me just see if I can go back to Brightspace, and then I can go to Lecture PowerPoints, and then let's look at 2. Okay, look at this one. This is it.
Aaron.
So this is the thing that we had to do, where we counted the frequency in the data set. And then we did the cumulative frequency in a data set.
Oh, I remember.
And then, yeah, we had to do the cumulative relative. It's a throwback. It's a throwback for real.
Shit.
Yeah. That's going to be on the exam.
Dude, I don't remember this.
It's okay. We're going to go over it.
18.
Yeah.
Wait, I never understood it. Like, what do you mean?
That's so fair.
No, I mean, I did understand at some point.
Yeah.
Then we went over it.
See if you can find it in your notes.
I have it.
Mm-hmm. You take hella good notes, so you'll recognize your own handwriting, I bet.
That is true.
Mm-hmm.
I can do that. Chapter 2, review.
Look at you. You have little bookmarks and everything. That's crazy.
Because I take notes very messy, so at the end of the chapter, I just make a little review page.
That's so cute, bro. That's so cute.
This is your chart.
Oh my god. That's so cute. Oh my god, I love it. Your handwriting's so nice.
No.
For real.
What about this?
See? Look, you even color-coded it.
Yeah. I can't read it.
I can go over it right now, don't you worry.
Okay.
Mm-hmm. So, all you gotta know is this is what might be thrown at you, okay? She might throw a data set at you. It'll be like 1, 2, 3, 4, 4. And you're like, oh shit, what am I supposed to do with that? Well, you have to make a chart. So the first thing you gotta do is you put all your data points from highest to lowest. So first number would be?
4.
Yeah. Second?
Low, 1.
Yeah, highest to lowest 1. So it would be like 1, 2, 3, 4. So these are all the different data points that we see.
Right.
Right?
Yes.
Data points. Now we gotta count up the frequency.
2, 1, 1, 2.
Yep. And then there's something called cumulative frequency. And essentially what it is it's gonna be n and then n minus frequency. So it's gonna start off at 1, 2, 3, 4, 5, 6. It's going to be at 6, and then it's going to be 4, and then it's going to be 3,
2, and 0.
And then 0. Yeah, and that's how you know you did it right. So all it is just n is at the top. So we start off at like 100, like cumulative, all of it cumulatively is like 6.
Yeah.
And then we do n minus this,
And then
f1,
zero
n minus f2, and then you keep going all the way down. Yeah. And then the very end should be 0, but we don't put that in. We just know. And then so that's cumulative frequency. Now there's relative frequency. Relative frequency. And what this is it's going to be the frequency divided by the total number. So we have frequency 2 divided by the total number 6. Now we have frequency divided by the total number 6. Frequency
so we did that to like show a percentage?
Yeah, the proportion.
The proportion.
Yeah. No, because this is going to be a decimal. It won't be a percentage. It's just going to be like, 2 divided by 6 is not it's not going to be like a percent. It's just going to be a decimal.
Yeah.
It'll be like, I don't even know, 1/3, 0.33 something, I think.
And CRF, cumulative relative frequency?
Yeah. So after we have cumulative frequency, right? And then we have relative frequency. And now the last one is, the second to last one, cumulative relative frequency. And what this is it's crazy. It's just 1 at the top and then 1 minus this. So it's the same thing. We're just going down. So 1 minus 3.3333 would be like, I want to say 66666, yeah, 67. And then we would do.
Okay, I can't do that.
1, 5, and 5, 6, 7, 1, 7, 5. So you would just keep subtracting essentially. So it's going to be 1 at the top like we did before, and then 1 minus the relative frequency. And then 1 minus the relative frequency minus the relative frequency, and you just keep going down, all the way down. And this is the last one, I promise. I think you promise, okay?
No, that's it. Actually, it makes sense.
This is the last one. This is cumulative percentage frequency. And this is where we get the cumulative percentage polygon.
Oh, okay.
See? Okay, so all that is you do this times 100.
Oh.
Yeah.
Oh, sweet. Okay.
So, in review, we've got just the pure data points. We're not doing 4, 4, 3, 2, 1, 1. Okay, we're just doing all the different types.
Yes.
And then their frequencies. And then cumulative frequency is just going to be n, and then n minus the f1, n minus f1 minus f2, and you have to keep going down. And then relative frequency is going to be fn. So the frequency divided by this, the total number. And then cumulative relative frequency is just like this, but it's just 1 and 1 minus RF. 1 minus RF. Minus RF. And it keeps going down. And then you just multiply it by 100.
Yes.
So I know that's a lot. See if you can make the chart yourself. And let's imagine I gave you like 1, 1, 1, 2, 3, 4, 4, 4. Data point.
Frequency
From high to low.
CF is a cumulative. Yeah, cumulative. Frequency, and then there's relative. Frequency, and then there's cumulative relative.
Cumulative relative frequency.
And then the other one's flipped the other way, right? Or is it just percent of it?
Yeah. So all this one is combining these two letters. So it's cumulative relative frequency.
I forget the next one, is it?
And then you just multiply it by 100. So when you turn a decimal into
What is that called?
percentage.
Oh,
Cumulative percentage frequency. Because now
Oh.
it's just in a percentage form.
Cumulative percentage frequency.
So see how it kind of builds on itself? It's like cumulative, and then relative, and then cumulative relative, and then it's like cumulative percentage.
That point, 1, 2, 3, 4, 3.
Check that for a second.
Huh?
And go from high to low.
High. Oh, high.
Mhm. Or else it'll fuck it up when you're subtracting.
4, 5.
It's really, really, yeah. It feels counterintuitive.
Then what we're gonna do over here. Shit.
You got this.
I think I forgot. No.
What is n?
You start from the total and you subtract it. So.
How many data points are there?
3, 5. Wait, no, I'm adding that. That's 8. 8 data points.
Yeah. So slay. So you put 8 up there.
8, and then you subtract 5. 4.
4 minus 1 is 3. Yeah.
Oh.
And then.
This way.
Yeah, I mean, you can do it that way, yeah. Yeah, that works.
No, that's wrong.
No, you do it right.
What just happened?
You just do it that way.
Oh.
So it's like steps, kind of like you do 8 minus 3 equals 5. 5 minus 1 equals 1.
Oh my god.
You got it.
That's so
Mhm.
silly. And then,
if that's too confusing, like the steps, you can also think just n and then n minus frequency 1, n minus frequency 2. So you can think about it that way if you'd like.
and then relative, you start from 1.
That's this one.
I need a calculator. Oh no. Bro, we just went over this. This is stupid.
No! Don't at all. This is like crazy complicated, bro. There's like 6 billion steps.
Oh, it is.
Yeah, it is. There's like 6 billion steps. You have to do all the numbers. This took me 2 days to learn, so don't say that this is stupid, because then that means I'm stupid.
No.
Okay.
Frequency. It's
You
like
got this.
relative proportions.
Yeah.
Proportions for what?
So if you're starting at 1 here, let's write 1, and you're subtracting something,
Yes.
and then you're getting a lesser number, and you're getting a lesser number, lesser number, lesser number. So that means that this is decimal of some sort.
Oh, is it that,
You got this.
I'm not sure.
Remember how I talked about this?
3, 8,
Yeah.
and then 9, is that?
Yeah, that's it.
Okay.
So it's just frequency divided by n. Okay?
Frequency divided by n.
What I really don't want you to forget is all the little formulas that you have to learn around the way. So like, that's why it's so complicated, right? It's because it's not just a graph. You have to do the crazy ass formulas for each one. So,
Like that.
yeah. Just take it slow. Don't break your brain. You've got it. I'll do this calculation for you. Here, let's see.
Is it on?
Yes. Sorry, this is like a different one than I have.
Yeah.
3 divided by 8 equals 375. So 0.375. Sorry, 0.3.
Oh.
There you go. Okay, now it's going to be 1 divided by 8. And that's going to be 0.125. And then now it's
Oh, it's all the same.
And then, yeah.
Sweet. And then you subtract this way again.
Yeah. And then 1 minus 0.375 is Yeah. Whoa. Holy shit, girl. Damn. Okay. Queen.
I can do addition.
You can do subtraction. That's crazy. That's insane.
I can eat elementary. Oh wait.
Oh wait.
No.
Let's just say that it's perfect.
Wait,
Let's
0. Wait, no.
Wait,
What happened?
No. We're gonna fix it. We're gonna fix it. 0.375 equals 0.625.
Yeah.
Okay, we got that right. And then minus
125.
0.125. Okay, it's 0.5, and 0.5 minus 0.125 equals 0.375.
Yeah.
Okay, and then 0.375 minus 375 equals 0.
Zero?
Oh yeah, so it's just because it's like a little off that way. You got it right. You got it right.
Dumbass.
Yeah, you got it right.
I had 5 rows.
No, it's like this, and then this, and then this. I see it
Yeah,
now.
I had over there, and then I put
Yeah.
0.
I don't know. No, I see it now. It's just like rows.
So goofy.
Okay, this is the easy part. Yes, 100%.
My favorite part. Wait.
Yeah, that's it.
Wait. Oh, yay.
Yeah!
I just need to remember it's this way.
Yeah.
This and that.
Yeah.
Okay. Thanks.
Pop quiz. Just see if you can write the formulas. Okay? Just see if you can write the formulas for these words. Okay?
Yes.
You got this.
No formula for that.
No formula.
I mean,
you
I
just
can
count.
write out 10. That's like
Yeah, you count.
Yeah.
You count the frequency. I feel like you got that down. Yeah.
Frequency 1. No.
You start at just n.
Oh shit. Okay.
Yeah.
Start at n, and then we're gonna take out f1.
So you do the little step. Yep, you got it.
And f2.
You got it.
And
And then so on and so forth.
And this one, you divide.
Divided by n. Perfect.
Do you have a formula for that? Or
Yeah. So you start off at 1,
and just subtract.
and then you do 1 minus what?
Let's do that.
Yeah. Yeah, you can call it that, or you can call it relative frequency.
Oh, true.
Because you're just, subtracting it that way.
That's messy, but it's
No, you got it. And then times 100. Perfect. You did it.
Yay! Thanks.
Okay. And then I think.
That took me so long.
No, it didn't. Bro, I learned this in like 2 days. You did that insanely fast. Okay. So all that it is now is we're doing like. I think it's like. I'm trying to remember. I know that it gets taller. I know that because all that it's doing is it's measuring this. So it's like 37 and then 50 and then 62.5 and 100. So it's just getting taller and taller and taller because we're going that way. This is a little goofy in my memory. But all I remember is that you connect it to the back part, like here. I think it's called the upper limit. You connect it to the upper limit. And then this is the lower limit. We might have to look at your notes on how to make a little polygon thing. Yeah, it keeps going up. And yeah.
Yay!
Yay! Yeah.
Oh, okay.
Okay, so just connect it to the upper limit.
Upper limits. I need to have that upper limit. Just connect upper limit, and it always goes up.
Yeah, it always goes up.
That.
Yeah.
Okay.
You got it?
Yes.
Okay, so that's
Next.
that's one of them. Let's see.
Where is it?
Where did it go?
This one? We just did that, and then percentile and percentile.
You're forgetting stem and leaf block. Do you remember that one?
I want to forget it. But yeah, I do remember that.
Okay.
Stem is like
Imagine.
big letter, and then
Yeah, I had like
just smaller one.
2, 2, 1. What would it look like?
32, 30 to 31.
Yeah, slay. Okay, so that's stem and leaf. What about? Do you remember this one?
Oh no. have notes that you taught.
I think,
Median
and then
in the middle.
Yep.
Right.
Median.
And then outliers are the ones that are outside everything.
Yep.
Those are them. And then upper limit and lower limit? Or upper extreme and lower extreme? Is that what it is?
Yeah, upper. Inner fence. Is it called a fence? I think it's called a fence. I think it's upper fence. And then this is the adjacent value.
Oh, hinge.
And then this is hinge. This is upper hinge.
Mm-hmm.
And then
what is AV?
Adjacent value. It's, yeah. You got this. You got this.
It's spread. Also this.
What is the formula that you taught me and then I immediately forgot? It's for like figuring out
I remember like talking about it, but I don't remember the formula.
Let's
Let me find it.
see.
It's somewhere here. Somewhere.
It's like 1/2 of the SIQR or some shit. I don't even know.
Oh, here.
It's like what?
Lower
the-
fence and upper fence.
Yeah. Okay. It's 1.5 of the H spread. Okay. Lower hinge and upper hinge. Okay. Okay.
The best.
Okay. Why don't you draw that out? I'm gonna pass it off to you.
I have a nicer.
Yeah. Okay. Draw that little box. You go. No, go for it. Yep. Fuck that shit up.
We got them.
Mhm.
And no, they're not fences. Are they fences?
Yeah, they're fences.
So this is adjacent
Wait.
value?
Yeah, that's adjacent value.
What's the limit then?
The limit is, yeah, is it called fences or limit? Did I make fence up?
No.
Like,
Some of them I missed notes, so I just copied it from Google, so like they use
Okay.
different terms.
yeah.
But I don't think it's you.
I know that these are hinges because I imagine this is a door.
I remember that too. Hinges. Upper hinge and lower hinge.
Mhm. And they're also a percentile or a quartile.
Upper quartile.
But they're a specific quartile. Quartile?
75 was it?
Yeah, 75, you're right.
75.
And then the median is like 50 because the median is 50. And then the lower one?
75.
So the quartile will just be third, second, first.
And is this one also called adjacent value?
Yeah.
Oh.
It's just completely reflected. It's like a mirror. There'll be adjacent value, and this will be fence.
And what's this?
You mean this part?
Nah, this.
Oh, so this is the fence. So
Oh, this is a fence.
yeah, the inner fences I think they're called. And don't forget about the O. What's the O called? They're O for outlier.
What? I feel like I'm forgetting something.
There's something that's right here.
Oh, shit. It's IQR, but also called.
I think of it as hinge spread. H spread.
Oh, smart.
Mhm.
Wait, do you remember what H spread is?
Yeah.
I don't.
It's the same as SIQR, I think, or is it IQR? It's just quadrant 3 minus quadrant 1 all over 2. And then that's SIQR. And then Or you can think of I, Q, R divided by 2 is S, I, Q, R. It's the same thing. It's just that this right here.
And then fences. Their formula. Lower fence.
Upper fence.
Minus 1.5 times H spread. Is that legible? And then,
Lower fence minus 1.5
yeah.
equals a fence. Upper fence. Wait.
Wait.
Are you solving for a lower fence or are you subtracting?
Hinge.
Oh.
Yikes.
Okay. So it's the hinge minus 1.5 the spread equals. Wow, that's weird. Okay. That sounds right though.
Mm.
It's that the hinge minus the spread equals.
Oh. Yes.
Okay. Hinge minus, not divided. Minus 1.5 the spread equals that. Okay. So if we were to think about it in order, it would be outlier, and then inner fence, and then adjacent value, and then hinge, median, hinge, adjacent value, fence, and then outliers. It's kind of like a weird mirror.
Yeah.
It's kind of like a fucked mirror.
I hate this.
I know.
Okay. At least we reviewed it, so it'll stay in our brain.
Mm-hmm.
We just need to look at it again. You know what? What's after this? Well, we did sanity, we did percentile and percentile rank.
What's the difference?
You rank percentile. That is percentile rank. Sorry, I don't know.
I guess we'll never know. I'll come back to that one. Do you remember the skews?
Yeah.
This, and then there's this, and then there's this. It's like a roller coaster. We're going places.
Positive.
Mm-hmm.
Normal. But I keep forgetting. Okay, tell me if I'm wrong. Normal. And then negative.
Mm-hmm.
And then median will always be in the middle. Kind of. No, but
Yeah.
median, mode, and mean, and normal distribution, they're all in the same place. But then, is it the mean that's always facing inward?
Yeah, the mean is always facing inward. Kind of think of it as like it really loves the roller coaster. It'll always go towards the roller coaster.
Mm-hmm. And then median is there.
Yeah, median is there. You got it.
And then mode.
Yeah.
Is there anything else we should remember about this?
There's floor and ceiling effects. Do you remember what it means?
Yeah, if it's like shifted by the lower values that are too frequent, that is called floor effect.
Mm-hmm. You got it.
And then the other way is ceiling.
Yeah.
I remember this.
Yeah. There you go. Woo! And that's it. You get that one. Down easy. Okay. Oh, central dependency and dispersion. It's the graph that I taught you.
I remember that.
Really? Okay.
No,
Okay. Okay, so there's 3 things about like a little distribution that we want to know.
Yes.
3 things.
Center.
Uh-huh.
Shape.
Yeah. And?
Center. Spread.
Yes. You got it! Okay, we want to do center first?
Yes. Oh, sorry.
Center is the stuff that we've been talking about all semester. You just did the center, silly.
Yeah.
So it's those 3 things.
Mm-hmm.
The M,
median
M.
is the best.
Yes.
Kinda. Yeah.
Let's go through them. Let's go through a mean, median, and mode, and when to use them. So mean, we love the mean, but only when it's a normal distribution. Because remember, when we have a skew, what happens to the mean?
It shifts towards.
Yeah. It loves that freaking roller coaster, so it gets like biased and shit. It's unreliable. It's like, ooh, yay, rather than actually being in the middle. right? So we only like it when it's perfect. If it's even skewed a little bit, then we like this guy. Okay? But imagine what if we had bimodal. Then the mode, which is all that the mode means is it's like the most frequent little part. We would want to use the mode. Yeah, that's pretty much the basics of it. If you want to get more crazy, what is the measure of spread associated with the mean? Think of a normal distribution. You got the mean in the middle. What's the spread?
What?
Think about, like, remember we were talking about, this is the mean, and then we usually have like this. What is different distance? It's standard deviation.
Oh, yes.
Standard deviation, or S.
What is?
S is like.
Oh yeah,
But with sample.
Yeah, but what does that have to do with the mean?
It's so if you're using this center, then this is the wave spread that we like to use. But if you're using this, then we like to use SIQR. So they have little ways of spread associated with them. Like if you had median, you wouldn't want to use like this. Does that make sense? Or if you use like mean, you wouldn't want to use SIQR.
Center spread. Shape.
Yeah.
So this is center. Shape. And spread. But then how about range? Is that useful anytime? Because like, isn't that the worst thing ever? Because it's so affected by the outliers.
Range?
And you don't want it.
It's kind of associated with median. Yeah, we also talk about range. That's just the lowest to the highest, and it's like super unreliable. We don't usually fuck with it. We only do this mainly.
Sweet.
What else? What else is there? What else? Yeah. So pop quiz. Well, what center would you want to use if it looked like this?
Median.
Yeah. Median. Because what happens to the mean?
Because it would shift towards the other side.
I love the roller coaster. Yeah. What about a perfect one?
All three's fine, but you would want median. No. Oh, mean.
You want mean. Mean is
everything is in the middle, anyways, right?
Yeah. Everything is in the middle, and mean is the best one. Like mean is queen, king, whatever. Crown. What else?
I think someone's texting. Outliers? Which is least impacted by outliers? Or not at all?
Do you know?
Yeah, you told me, and I wrote it down.
Oh, okay, slay! That's so slay!
No, I just copied your chart. That's all I did.
You did
I
it!
did not slay, I just copied your chart.
The fact that you can copy is slay.
You sent me a video. Stop!
I can't copy, bro. My handwriting's shit. Look at me.
No.
We're getting it. I'm proud of your effort.
Thanks.
Yeah.
I think we went over everything.
Yeah.
Dealing with 3 ways of dealing with outliers, ma'am. Do you remember?
3 ways of dealing with outliers. Oh, you can snip them. You can it's called trimming.
Yes.
You can Winsorize them, which is just replacing them. What else? What's the third one?
It's not necessarily dealing with outliers. It's just like what if your numbers are in thousands and you don't want that?
You linear transformation them. Linear transformation them. Oh yes.
That's it for chapter 3. Was that 3? Yeah.
Look at us. Look at us.
The test is on chapter 1 to 4, right?
Yeah.
Okay. 4.
And you just reviewed 4.
Yeah, I did it last night.
So slay. Okay. Want to teach me? What's it about?
Sure thing. I'm not sure. I can't like teach in a clever way like you.
That's okay. Just speak shit and I will get it.
All I did was just organize the notes.
All right.
Chapter 4 is about standardized scores and normal distribution.
Wow.
I know.
That's crazy.
Z-score. I think this is chapter 4 was when the whole Z-score thing was introduced.